Hello everyone. In our last AI shows, we have introduced to you Anomaly Detector as the API service hosted on the cloud, which is an AI-powered anomaly detection service. We also introduced the containers of Anomaly Detector, which is bringing the same capability to your premises. Anomaly Detector has /last endpoint, which is basically suitable for the streaming scenarios. And we also introduced that you need to have an application, basically an application that's a caller that prepare the data and call the REST API. In this show, I'm going to share with you a real-life solution that's built with Anomaly Detector /last API. It's a streaming solution, and the compute infrastructure for the application that's playing as the role of a caller is Azure Databricks. So the business problem that this demo system tries to address is that we like to monitor how people favor the tweets with the keyword #Azure. The KPI is denoted by the number of likes of those tweets. We extract the post time and the number of likes of each tweet as a key metric, which form a randomly distributed time series. With that, after an aggregation, we have an evenly distributed time series to be monitored by Anomaly Detector in a streaming fashion. This is the solution architecture. Twitter, being a data source, generates real-life streaming data as people post new tweets. In this blue rectangle, which represents Azure Databricks, there is this first producer notebook, which basically runs recurring queries against Twitter APIs to retrieve the tweets with #Azure and then extracts the number of likes and post time of each tweet. And finally sends the data as events to Azure Event Hubs. Then the second consumer notebook connects to the event hubs and listens to new events. It runs an hourly aggregation to get an evenly distributed time series and calls the Anomaly Detector APIs with that data. Before we dive into the code and demo, one thing worth mentioning is that although we are using Azure Databricks as the compute engine, in real-life solutions, you could use virtually any compute infrastructure for your application. It could be Azure Databricks, Azure Notebooks, Jupyter Notebooks, Azure Functions, or any IaaS on-premise infrastructure. Power BI can also do this. This demo is actually following the tutorial on Azure documentation of Anomaly Detector. I've created a short URL for you, aka.ms/adtutorial_adb. You can go there, follow the tutorial step by step, and do the same thing that I'm going to show you. You need to create an Azure Event Hubs namespace and Event Hub, and grab the connection string from there. So I'm not going to show how to create that, but there's a quick link here if you don't know how to do that. And there's also this Azure Databricks workspace. In this tutorial, we have the detailed steps with screenshots here, which can guide you to create a Azure Databricks workspace. One thing that's worth mentioning is, for this demo purpose, do not choose trial for the pricing tier. It will not work for the code that we are going to run. Normally, it takes several minutes to create an Azure Databricks workspace. And with that, what you can do is then create a Spark cluster. I'm going to show you. It's pretty straightforward. Go to the workspace resource on Azure portal and click Launch Workspace, and then your in the Databricks workspace. So there you go. This is the workspace. There's a link here, new cluster. We can click it. You can specify any name for the cluster, but remember to select 5.2 in the dropdown with Scala 2.11 and Spark 240 for our demo purpose. Otherwise, there's compatibility issue with the code. You can leave the rest as default, but you do want to check that this parameter terminates after how many minutes of inactivity is specified. This ensures that when you finish your demo, finish building the solution, the cluster will not cost you. When the cluster is being created, we can go to the tutorial and check out the next step. So now it's about, because what we are going to do is to have an application that's reading data from Twitter through Twitter APIs. So you need to have a Twitter application and a Twitter developer account, which will give you the API keys and the credentials you needed. So that's something that I'm not going to show here, but there are detailed tutorials, detailed steps described in this tutorial. You can follow that and get the API key, get the consumer key, the consumer secret, and the token, which we will use in the notebook that's reading data from Twitter. So once the cluster is created, what you need to do next is to attach libraries to the cluster. Because you want to run code, it will use two additional libraries, one for reading data from event hubs and the other for reading data from Twitter. Actually, for event hub, it's more like read and write. So one writing and the other notebook will be reading from it. So what you're gonna do is, in this workspace, there's the drop down here, and under create, there's this library. Just remember to select Maven and import the coordinates exactly as it is on the tutorial, because all that matters is the version again. The latest version actually doesn't work due to a few reasons. So you're gonna repeat the same steps for both libraries. Once the libraries are created, you want to attach the library to the cluster that you previously created. You can do it from the Azure Databricks workspace. Click the workspace button here, and on the shared, there are these libraries. Click on each one of them. As you can see, all your clusters will be listed here. And when it's running, my cluster is still starting, but when it's running, you can actually select it and install the library on the cluster. In the tutorial, there's this screenshot. This means it's properly installed. And you're gonna repeat the same steps for the two libraries, Event Hub library and the Twitter library. Now the next step is about getting an Anomaly Detector API key. So that's pretty straightforward if you have watched our previous shows. But in this tutorial, I've got this link, this quick link for you, where you can directly jump into the blade for creating an Anomaly Detector resource. And the key here is to get the endpoint and the access keys. Once all that is set up, you're ready to create the notebook and play with the notebooks in Databricks. Now, all those prerequisites are prepared. We are ready to play with the notebooks. So what you're gonna do is go to the cluster and create 2 notebooks. I've already created them. Let's check them out. So the first notebook is basically a data producer. You can grab everything from this code block in the tutorial, copy it, and paste it in your notebook. Remember to replace all the placeholders with your keys that you got from Twitter and from event hubs. So there are 2 parts of placeholders that you want to replace. This is exactly based on the tutorial code. You click Shift Enter, it runs. This is my previous run result. When this runs, it actually loads data from Twitter and send over the timestamp and the likes, the number of likes, to event hubs as events. Let's now go to the second notebook. So if you go through the tutorial, the second notebook actually starts from here. And it's split into different blocks with different functionality. The first one is basically defining the Anomaly Detector object. It's kind of a class with the 2 functions, detect latest point and detect batch. What we are using in this demo is detect latest point. And nextly, it's an aggregation function, or basically it's a function that will be used, class that will be used later to detect anomalies. As you can see, it's calling the detect latest point function defined previously using the time series data. So let's run it in the Databricks workspace. You can merge them into one block or split them. It will work the same. The next block is about loading data. So you need to specify a connection string. And this connection string is the same connection string with the producer notebook, the same event hub. The producer sends data, write data to the event hub, and this one reads data from it. Now the data is being loaded. Let me switch to a table view. So this is the data that's being sent to the event hub by the other notebook. The beauty of Databricks, of this notebook, is you can switch between the table and different chart views. And because it's streaming, so you can see the data is constantly coming in. The producer notebook is still running, and now the consumer notebook is also running in a streaming fashion that's constantly loading data. Now the next part is about aggregation. If you see into details about the data that's loaded from Event Hub, the data is basically randomly distributed. It depends on when the Twitter is posted. You can also view that from the chart. This is dense here and sparse here, right? In our previous AI shows, we've mentioned that if you have randomly distributed data on timeline, you may want to aggregate or even sample from the randomly distributed data in order to form evenly distributed data. So this is the code block that's doing the job of aggregation. This is still streaming. As you can see, new data is coming in, and the timestamp is now evenly distributed. The aggregation is basically an average over the 1 hour, every 1 hour. You can use max or whatever that's favorable. It doesn't matter, it doesn't change how you're going to use the API. And you are getting the data that the API requires, evenly distributed data, hourly distributed time series, like this. The next part is output this aggregation result to Delta. So Delta is a data lake storage in Azure Databricks. It's a table storage. If you copy the code from the tutorial, there will be the placeholders for the table name and for the checkpoint names. You need to replace that with the real names. And then let's run this. And the next part is showing aggregation result. Because the previous block basically only write data into the storage, and the display function here is able to show the data, show the aggregated data. As you can see, there are already 232 data points in table view like this, and this is chart view. The last part is anomaly detection. As you can see, it specifies a batch size, which is basically when your window or sliding window of the time series data starts. This part will call the API with a sliding window of data starts from 72 hours ago and ends at now. But this part that I've selected prepares the data, and this line 32, is actually calling all the aggregation function and the class defined above. That's really running and calling the API with the data that we prepared here. And finally, these two lines are going to show the result. Let me just run it. So when it's running, let's scroll back to the data, and you can see it could be taking 72 data points from here. Actually, now it's June 14th. So the data that's flowing into this storage hasn't come to today yet. So I'm expecting a false yes. So basically, there's no data. Let me change this. For demo purpose, you can change the end value to a data point where there is data. So let's start with something normal. Or actually, let's start with something looks abnormal. Something extreme, like this one. It's June 2nd and 0 a.m. So I'm going to replace this with 2 and 0. Run it again. Hopefully it will be a true, which means an anomaly. Yes, there we go. So this data point is an anomalous one, and let's replace the value with something like this. So 1600, June 3rd. And run it again. Hopefully we will get a false, because this looks to me like within the normal range. There we go. Perfect. So with that, we are calling the API and getting the result. But this is basically running once with a sliding window, and because it's calling the last API, it's telling you the last data point that's specified by the end time here, whether it's anomalous or not. In real life, you may want to define some job that's calling this part in a regular cadence. So that's how the sliding window works. And the result in this block is just a small table here showing you whether it's true or false. In your production environment, you may want to leverage the result with some visualization tools like Power BI, or with your own monitoring systems. And the other option is to leverage the result. When there's an anomaly, you can trigger some alert or some automated actions. Okay, that's it. So you have this job defined in Azure Databricks that helps you detect anomalies from your favorite tweets. Of course, you could run it against any streaming data in your real-life production environment. The data could flow from event hubs, IoT Hub, or any streaming data source. Check out this tutorial that you can follow step by step to create the same application that I've just shown you on aka.ms AD tutorial ADB. And you can also go to aka.ms/anomaly detector to check out the overview of this service, or you can search on Bing for Azure Anomaly Detector. We also have a Microsoft Teams channel, a community of Anomaly Detector customers and the Microsoft engineering team of Anomaly Detector. If you'd like to join that, please go to ak.ms/adadvisorsjoin to fill out a short form. If you want to check out the containers to run the APIs on your premise, go to ak.ms/adcontainer to fill out a form to let us know your scenario, and we will share with you the credential that you can use to download the image from Azure Container Registry. Thank you for watching. See you next time.